All right, the first video for your series this week is going to be about matrix multiplication. So remember, anytime we are multiplying a matrix by a vector, you are doing a transformation, right? We had T of x equals B times x in this case. And so then if I'm multiplying again by A, notice where that goes. It goes into the front, right? So that way it's A times B times vector x, because you need to apply vector or the multiplication of matrix B onto x first and then multiply here. Now notice that this is a composition of mappings. We talked about composition functions back in college algebra and your calculus series. So a composition of mappings means that first you're going to work on the inside piece on x and then the outside piece. But it is also true that you can multiply A and B together, and then that becomes the transformation on x. So in this case, that transformation on vector x is AB, and then multiplied by x, and you can see that here. If A is an M by N matrix, and then B is an N by P matrix, we have different column vectors inside B, then that product AB is then going to be the M times P matrix. That makes sense because I'm multiplying here and an N, so I get M times P. And then those column vectors are going to be the matrix A times each and every piece here, or the matrix A times, you can multiply it through that way. Okay, so just making sure that all the things from that first chapter, we're just kind of bringing them together into what a composition would be, a composition of mapping, okay? And noticing that that composition is still a linear transformation. Okay, so how we are going to do this, we did this a little bit before, but what you're going to do is you are going to be multiplying each row by the associated column, and there's this IJ notation that is used when we do so, but I want to just show you kind of how to do that here in this example. So if I'm multiplying A times B, I'm going to take matrix A and then multiply by matrix B, and I'm going to make sure that if I am in this row, row 1, then I'm going to be multiplying by this first column. This is a 2 by 2, and I'm multiplying by 2 by 3, so our result is going to end up being a 2 by 3. And so that first piece is 2 times 4 plus 3 times 1. Then I go to the next row. So this row, the next column, this row times this column. So 2 times 3, 6, minus 2 times negative 3, or plus rather, 2 times negative 3, negative 6. Last column, 2, 3 times 6, and 3. So that's going to be 2 times 3, 12, plus 3 times, or 2 times 6, 12, and then plus 3 times 3, which is 9. All right, let's go ahead and do the bottom. We're going to do the same thing. 1 times 4 plus negative 5 times 1, 1 times 3 plus negative 5 times negative 2, 1 times 6 plus negative 5 times 3. And so my result is going to be 11, 0, 21, negative 1, 13, and negative 9. And that's how we are going to term by term find our matrix when we do matrix multiplication. And again, that's a little bit more of a concrete example as to how this computing formula works. All right, let's look at another example here. If A is a 3 by 5 and B is a 5 by 2, what are the sizes of AB and BA if they are defined? Well, A times B, 3 by 5 times 5 by 2, we're good here. So that result is going to be a 3 by 2 matrix. All right, B times A, 5 by 2 multiplied by a 3 by 5, cannot do that. That's going to be not defined. Because remember, you have to have the number of columns in the first one has to equal the number of rows in the second one. So that's not going to work if we want to do B times A.